So here I'm talking to my local LLM through this graphical user interface, and I'm not just getting the responses back, but I'm also getting important metrics like end-to-end latency, the total token being used, and there's a breakdown of the prompt token versus the completion token. So in this video, I'll show you how I got here. But before we dive into the terminal and start the lab, let's quickly talk through the technical design of what made it possible, and then we'll get started with the lab. So this is the high level technical design that makes this Kubernetes cluster, and then that makes the GUI possible. So we have two important parts here. First part is vLLM part. So essentially this is the part where our model lives. This part is responsible for talking to the GPU. It does all the inference and heavy lifting here. There are two important downloads that this part processes, right? So it downloads the model from Hugging Face. After it downloads the model, then it has to download the vLLM image from Docker as well, right? So it has those two massive downloads. After those downloads are completed, this part is ready to serve all the requests. And then the other part we have is our FastAPI part, which is responsible for creating this particular GUI that you see here. And then what this does is that it only downloads one small custom image that has Python, HTML, and CSS codes from Docker. So after these two parts have their setup complete, these two parts have their respective service as well. So for GUI, we have a GUI service. For vLLM, we have vLLM service. So what this service do is that they find out the pods with app label, with the label app vLLM for vLLM related pods, and then for GUI, it finds the pod that has the label app GUI. So this is how you would map a service to a pod. Create a label in the pod saying that, okay, all of these pods are going to be app vLLM, and then in the service you can define that, okay, the service is responsible for dealing with all the pods that has the label app vLLM. So even in a cluster of, let's say, 1,000 different pods, you can use labels to match the right service to the right pod. So in our setup, we have a service-to-service communication. We don't want pod-to-pod communication, because if for some reason our vLLM pod dies and then a new vLLM pod is recreated, it will have a new IP address, right? So we have to go ahead and reconfigure our FastAPI pod as well. Say that, hey, the vLLM pod IP has changed. This is the IP that you have to use. So we want to avoid all of that reconfiguration, because with service, all we need to do is that, okay, this is the service that we're going to talk to. We don't care we don't care how many times that IP gets changed. If the pod is deleted, that's not going to be a problem, right? This configuration will keep that thing simple for us. So, and then we have another component in our cluster, which is a config map. So this is where we define all the variables that we need. So a couple of important variables that I've defined are like model ID. So if I want to interact with a different model, all I need to change is that particular variable here, and then I will interact with a different model. And then another one would be GPU memory utilization. For our current setup, we have told vLLM that you can use up to 90% of the GPU memory for your particular use case, where the model is being downloaded, and so on, right? So it's easy to keep a config map centralized like this. So all of these pods can download their necessary variables that they need from this particular config map. So that way, we keep a central source of variable declaration as well. And after all of this is set up, right, the way I talk to my graphical user interface is that since my machine is in vast.ai, this machine does not have a GUI access, right? It only has terminal access. So I have to do some port forward and some tunneling to make sure that I can access this thing from my laptop. So what I've done is on the GPU node, right? Since we have a service that has all the GUI that it needs for the pod, what I've done is I have a port forward in my node that says that any request coming to me on port 8080 should be sent to the GUI service on port 8080. So, and then from my desktop, I create a SSH tunnel that maps the port 8080 of my desktop to the remote machine. So when I go and when I say localhost 8080, essentially what's happening is that that request in my machine has been routed to my remote machine where I've said that, hey, any request that's on my localhost 8080 needs to go to my remote machine on 8080. But in turn, in my GPU machine, I'm saying that any request that comes to me on port 8080, send that to this particular service. That's how I'm able to access this GUI from my server, which only has terminal access in my local machine. So that's the entire setup. And then you've seen the UI, right? So the UI just looks like this. So let's go ahead and build this up. Okay, so okay, I have okay, this is watch NVIDIA. I have an SMI running in a loop. You can see there's basically no utilization so far. After I clone the repository, all I need to do is go to GPU FastAPI and then go vLLM container GPU. So here you will see vLLM UI and vLLM YAMLs. So the UI is there just to show you the code responsible for creating this UI. So I created an image using this particular Docker file and all the HTML and CSS. It's pretty simple, as you can see. It's a simple UI setup. It's in that particular directory. But for my use case, I have to go to vLLM underscore YAMLs. So if you have a look at here, you will see there's the vLLM pods, and then there are the GUI pods, right? So let's go ahead and pull this back up, and then let's have a look at the pods. So we'll go kubectl get pods -watch. Okay, so let's create our vLLM pod first. So let me go kubectl vLLM deploy.yaml. So let me actually pull this up here as well. So this is the pod that I'm creating now, and okay, I already created that pod before in this machine, so my image is already downloaded, so it does not need to perform a re-download again, so it should be quicker. After I do that, then I need to create a service for that pod. So I'll go kubectl apply -f vLLM service. Okay, so the service is created, and then I'll create my config map, this one here. So kubectl apply -f configmap.yaml. Okay, so now the vLLM side of things are completed. Let me go ahead and create my UI. So I'll go kubectl apply -f deploy UI.yaml, kubectl apply -f this is service UI.yaml. Okay, so we have created those two servers, those two pods, and then the config map that we need, right? So let's go ahead and see this. If I do kubectl get service, we can see I have two servers, right? One is vLLM API, and then another one is vLLM UI. So these two are the service that I was talking about. And we can see that for vLLM API, we're talking on port 8000. For my UI, I'm talking on port 8080. So between these two pods, you know, you can talk to vLLM pod on port 8000 if you want to talk to the pod directly, but we want to use the GUI setup, so we have to do a port forward, right? So by port forward, all I'm saying is that any request that comes to this particular machine, right, my GPU node, send that to that particular service. So to do that, I need to do kubectl port forward, and then mention the name of the service. In this case, this is vLLM-UI, and then I'm sending any request that comes to me on 8080. Send that request to the service on 8080, because that's where it's listening for that particular pod, right? So, and then let's send this process in the background with ampersand sign, and done. So to confirm this, we can run this command as source sockets TULNP telnet UDP listening ports, right? Giving the name of the ports. So if I go grep 8080, so see, we're listening on our local host on port 8080. So essentially that's what we wanted, right? So we will start listening for a request in this machine on port 8080. Okay, so now that part is complete. So the other part that I need to do is create an SSH tunnel, map the port 8080 of my desktop to my remote machine. So to do that is quite simple as well. So I'll go to my vast.ai console, and then when I click on connect option, I just have to copy this. And then, so let me refresh this. It should not work as of now. Okay, actually it did work because as you can see, my initial connection here, I already mapped my port 8080 to my localhost port 8080, right? So if what we can do to confirm this is, for instance, what I can run here is I can run kubectl port forward on, let's say, 8090, for example. So actually, let me kill this first. Kill dash 9 56235. Okay, I have killed that. Let me run a port forward on port 8090. Oh, sorry, on port 8080 for that, and then $80.90 for my local machine. Okay, so now this should not work, right? Okay, there we go. So the connection failed because we don't have this tunnel set up, right? So for me to work this tunnel setup, all I need to do is I need to say on my localhost 8090, map that to the localhost machine on port 8090 as well. So once that tunnel is established, right, that's all I had to do to set up to establish the tunnel over here. So now if I go to my localhost, but I need to go to localhost 8090 this time, right? So, and there we go. So essentially that's how I'm mapping my port request. Like that's how I'm kind of doing the port forward, right? So you can use any port for this particular situation. By default, I use 8080 because Fast.ai already kind of gives me that tunnel on port 8080, so that's why I used that. So now let's send a request to this model. Let me ask, okay, write me a one-page blog about SRE. So we can see the, oh, actually, let's have a look at the NVIDIA here. Watch NVIDIA, that's SMI. So there we go. We see the utilization is going up. We see the memory being used as well. All of these are the parameters that we declared in our config map. And then we get to see this response, right? So this is the response from our model. And then it took 14.96 seconds to complete this query. The prompt token was 39. It took 512 tokens to complete all of this. The total token used was 551. So yeah, that's that's kind of the topic that I wanted to cover for this video. And then bear in mind, like, the latency does actually go up a little bit in this particular setup because, see, our request is not just directly with the pod, right? From my desktop, like, the request goes through the SSH tunnel to the node. From the node, it goes to the GUI pod. From the GUI pod, it goes to the vLLM, right? So for a GUI setup, yes, this might be the way to go forward. But if you talk directly through APIs to APIs or directly through pod to pod, this time will be a bit slow. But it's not a big difference in time consumption. That latency is something that I can deal with, I'd say. So I think going forward, what I want to do is I want to create a Grafana dashboard that has these and other important metrics that are responsible for, my user interaction with my LLM model. And then imagine a setup, right, where you run an LLM service like this, like ChatGPT, for example, or any LLM service like Mistral AI, Gemini. And then these might be the metrics that you really want to monitor, right? Like, how long is it taking for my server to send the request back? How many tokens does it take? And then probably there are other more metrics that would be important. So I'll have a Grafana dashboard which will monitor every single request, and then it monitors how long it took. So for instance, if I see something like 16 seconds for maybe 50 tokens, now that is concerning for me, right? Because we see here that for 551 token, the average time it took is 14.96 seconds, right? So let's run that again and let's see if we see something similar. It depends on the total number of token being used, and for each response it might use different number of tokens. Okay, sending. Oh, okay. I think it took 13.58 seconds now. The number of token used is pretty similar. So let me say a 2-page blog about it, sorry. But yeah, like what I mean to say is that we kind of need to map like how long does it take for each token to be processed. Obviously, you know, the first token and then the last token are going to be different, but there we go. So it still used 551 token as max, and then but then the latency time was 13.56 seconds. So these might be the things that we want to monitor, right? But this will be things that we will build down the line in our Grafana dashboard. And yeah, thanks for watching this video, guys.